Welcome back. Thanks for joining me again in this lesson on creating an application load balancer. In this lesson, we're going to go through how to create an application load balancer, and we'll talk about ELB security groups and communication protocols. So the first thing we're going to do is pull up our instructions on how to configure our elastic load balancing, and then we're going to go to EC2 under Compute, and we're going to navigate under Load Balancing to Load Balancers. And notice that we don't currently have any load balancers, so we're going to go ahead and click the Create Load Balancer button. And notice that there are three different types of load balancers. Starting from the right, you have Classic Load Balancer. Classic Load Balancer is a previous generation load balancer that load balanced based on HTTP, HTTPS, and TCP. Notice that is grayed out because they really don't want you to use Classic Load Balancer anymore. Classic Load Balancer was really designed with the legacy EC2 Classic network. So instead, AWS prefers that you use either the network load balancer or the application load balancer. The network load balancer is really designed for use when you need ultra high performance and static IP addresses with your application, and the application load balancer is used when you more so need a flexible setup for your web applications based on HTTP and HTTPS. We're going to create an application load balancer. So we're going to go ahead and click Create. And the first thing we need to do is give our load balancer a name. So I gave the load balancer the name Omega ELB. We want it to be internet facing because we want it to be accessible to our users who are trying to access our web server from the internet. We're going to leave IP address type at IP4. And then below that, we have listeners. For listener, we set the protocol that's going to be used and the associated port. So HTTP, you see, is pre-selected for us with port 80, which is what we're going to use. You can also add HTTPS, but we're not going to add HTTPS because there's some additional more advanced configuration that has to be set up along with HTTPS. Okay, so I'm going to go ahead and select my VPC, which the correct one for me is the default VPC. I'm going to scroll down a little bit. And your VPC needs to have a minimum of 2 different availability zones configured with it. And I need to select 2 different availability zones, but I need to pick one that has public subnets configured in it. So I'm going to select 1B and 1F as my 2 availability zones. Then I'm going to go ahead and click Next to configure security settings. We don't see any settings here because we're not using HTTPS. As I said, there's some more advanced configuration that we would have to do. So we're just going to go ahead and click Configure Security Groups. Now here we see a list of our security groups. We're going to go ahead and select Essentials SG and uncheck the default security group. The Essentials security group, if you remember, we allowed our HTTP traffic with that security group. I'm going to go ahead and click Next to configure routing. And now we need to create a target group. So your load balancer is going to send traffic to targets. So our targets are essentially our EC2 instances. Your EC2 instances will essentially be part of a target group. And your elastic load balancer will perform a health check against the instances that are in your target group. So I'm going to call this Essentials TG for Essentials Target Group. Our protocol is HTTP port 80. That's all good. Our target type is instance. And we want to check HTTP on our servers. So essentially, our servers have to be serving a web page using HTTP and the path that they need to use. So think about how you access a website like linuxacademy.com. There's a default document there that ensures that a web page opens up when you go to access that website address. So this is assuming that you're using that default document as part of your health check. If not, then you would need to specify the path to the file that you want the elastic load balancer to use. It will check to ensure that that document or web page is up and working. And if it is, it passes the health check and is marked as healthy. If for some reason that path is not available, it would then be marked as unhealthy. When an instance is marked as unhealthy, then that instance can no longer be used by elastic load balancing. So I'm going to expand advanced health check and notice that there are thresholds. It's considered healthy after it passes the health check 5 times. It's considered unhealthy after failing the health check twice. And you're able to specify a timeout, how many seconds should pass between health checks. You also can specify what the status code should be. By default, status codes are 200. So next, we want to click Register Targets, and we're able to specify instances that should be used with the Elastic Load Balancer. So we're going to go ahead and check the box next to our web server and click Add to Registered. So now it's listed as a registered instance. Then we're going to go ahead and click Review. Everything looks good, so we're going to go ahead and click Create. So our load balancer was successfully created. So now we're going to go ahead and go to our load balancer, and notice that under our basic configuration, there's an exclamation point next to our load balancer name. If you see that exclamation point, you should be able to ignore that error message. The message is coming from AWS Config. AWS Config is a fully managed service that continuously captures changes to the configuration of your AWS resources and notifies you when those changes are detected. So essentially, AWS Config has recognized that we've made a configuration change, and as a result, it's sending us a notification. So you can ignore the exclamation point. So we're going to go ahead and click on Listeners. And notice that we have an HTTP listener here. So you can see our load balancer is all set up. We currently have the one EC2 instance set up as a listener within our Elastic Load Balancer. So now let's go ahead and summarize our requirements based off of Project Omega. Our requirement was to automate the process of distributing incoming external user traffic evenly across Project Omega's EC2 AWS resources. And we needed to provision an Elastic Load Balancer and have it properly configured and ready for use with auto-scaling. And we have met that requirement. We're going to talk about auto-scaling in another section. So that concludes this lesson on creating an Elastic Load Balancer. Thanks for watching, and I'll see you in the next video.